Hello. Today I'm going to be doing a video over adding vectors mathematically. So we had previously talked about adding vectors graphically with a picture, and I can show you that here. You see we have two vectors, the green vector, and I should have pinned that down, which I meant to do. I don't even know if I can do that. I think I can. Hold on, sorry. Locking place. Good, okay. So now, good. So we have two vectors. The green vector looks like, and I try to make it as close as I can to 2 units. Let's say these are velocities. So this is like 2 meters per second north. The red vector is as close as I can to 3 meters per second north. Or, I mean, east. 3 meters per second east. Sorry, I'm still trying to. There we go. All right, so you've got these two vectors, and we really want to add them. And as we talked about yesterday, to add them, all we would do is we would redraw one, right? You would take either, and we talked about it doesn't matter. The addition order doesn't matter. You would either go here, starting here at the tip of the green arrow, and redraw the red that way, or you could redraw the green starting at the tip of the red. The green would go up. Either way is going to give you the same result. Now, I can actually move the vectors, and if I can move the vectors, then I really just want to kind of pick it up and place it there. Cool. But now I want to draw the resultant. A lot of times people forget to draw the resultant, and it's a very important part. So I'm going to start at the origin. We always start at the origin with our resultant vector. And I'm going to go out to where we ended up, right here. Great. So this little black vector here represents the resultant of adding those two vectors. And of course, it points sort of northeast as we would expect. And it even points more east than north because, well, look, at the east vector is a little bit bigger than the north vector. And so it kind of makes sense that it's not perfectly, there. But this is a vector. We want to know more about this vector. We want to know what is the length, really. We want to know the magnitude of this vector. Okay, so I could try to take this vector and sort of guess, right? I mean, I can see that it's not going to be 3. Sometimes people want to say it's 3, but it won't be 3, right? If I stretch this out, I'm afraid to do it because I think I'll mess up my vector. I guess I can try it. Really cool. I'm sure there's a way I can move it without changing the size. But anyways, if I try to move this vector without stretching any further, we can see that it's going to be a little bit bigger than 3. I mean, 3 is like a okay guess, but it's going to be bigger. And so we want to know, well, what exactly is the length of that vector? And to see this, let's label a couple of things first. All right, you see that, first of all, this green vector, we actually know the length of this vector, right? I mean, we can just look at it. It's 2 units long. We said 2 meters, or 2 meters per second. So let's say it's 2 meters per second. And the unit's not really going to matter too much because any type of vector can be added like this. Okay, what about the red vector? Well, we can see it also is going to go over 3 units. So the red vector is going to have a magnitude of 3 meters per second. And so then the question is, well, what is the length of the black vector? And to analyze this, let's look at what we've created here, right? I mean, you can see this. What kind of shape have we made with these 3 vectors? Yes, hopefully. It feels like Blue's Clues. Maybe you said it out loud. Maybe you didn't. But it's a triangle. Of course it's a triangle. There's 3 sides, 3 points. It's a triangle. But we want to get more specific. What type of triangle is it? And of course, you remember we can identify triangles based on different properties like the angles and the sides. If we're going to go by sides, it looks to me at least like all 3 sides are different. So that means it would be a scalene. But what I care about is what type of angles does it have. There should be one angle that you see is very obviously a right angle here. And we'll mark it kind of like you do in math class, right angle. And we know this is a right angle because we have the y-axis and x-axis, which by definition are orthogonal to each other, or by definition create 90-degree angles between them. So this must be 90 degrees. And if this is 90 degrees, then what that means is that this triangle is a right triangle, which is good news for us because there is a lot of information we can know about right triangles. I will probably make a video soon about all about right triangles and trigonometry. But for now, it is important to know that this is a right triangle. So if we actually want to figure out what is the length of this vector, we can do that. Because there are 3 sides to this triangle, correct? And I'm asking what is the length of this side? That's the longest side. It's also the side opposite of the right angle. And that side has a name. It's called the hypotenuse. And let's hope I spelled that correctly. I think I did. Hypotenuse. So we want to know what is the length of the hypotenuse. Unfortunately for us, we have an equation that describes it. I think I have it over here. Yeah, you may not be able to see the very top. It just says Pythagorean theorem. But this is the Pythagorean theorem. If for some reason you don't have it memorized, which is fine, I would go ahead and write this down. If you feel like you know it well enough, then it's not that big of a deal. And you can pause and write that down if you need to. But one thing is really, sometimes people get confused about when we talk about right triangle, or the Pythagorean theorem, I should say. I had this Russian professor. He was so Russian that his name was Vladimir twice. His name was Vladimir, and I'm not making that up. That's first name, middle name. And he called it the Pythagorean theorem. So what is the deal with the Pythagorean theorem? Basically, we know that the hypotenuse, the square of the hypotenuse, is going to be the sum of the other 2 legs of the triangle. Now, sometimes people are like, well, which side's A, which side's B? It doesn't matter, right? Think about this. This is addition. You can do addition in any order. So yes, you could say this is A and that's B, and it's not really a change except it'll look like B squared plus A squared. But it doesn't matter, right? C does matter though. C has to be the hypotenuse. So we have A squared plus B squared, C squared. So let's go back and see what that means for us. Now on this one, there's no positive or negatives, and I'm just going to tell you when we get into 2-dimensional problems, which is where we're heading, the positive and negative stuff really gets thrown out the window. It will still be a little bit useful, as you'll see, but for the most part, it just really doesn't matter when we have like a north and an east, or a south and a west, or any 2 orthogonal directions. All right, so using the Pythagorean theorem, we know that this side is 3 and 2. So this is going to be my hypotenuse. So if I write out the whole Pythagorean theorem, I have A squared, which I'll just say that this side is A. 2 squared plus B squared equals C squared. All right, well, I'm going to get 2 squared is 4 plus 3 squared is 9 equals C squared. In other words, C squared must be 13. 13 is equal to C squared. Now, do not stop there. Obviously, you should see that this isn't 13. I mean, 13 isn't even on here, right? So if it was 13, it would be like all the way over here and terminate over here. So it's not 13, but 13 is C squared. So whatever the actual length of this, the magnitude of that number squared should be 13. So you can just take, obviously we're trying to get C by itself, so we have to do the opposite function. The opposite function of squaring is to take the square root. So I would square root both sides. So if I took square root, I get that C is just the square root of 13. Now, if you want to leave it like that, that's fine with me. Most people like to see it as a decimal, though, and that's fine as well. So you can just plug it into your calculator, and you'll get 3.6. I'll round it to about 3.6. We'll call it 3.61 if you want. Meters per second, of course. Don't forget your unit, meters per second. And then when we talk about the direction, for now, we're just going to say kind of northeast will work. Northeast. All right, 3.61 meters per second northeast. And that kind of matched up with what we said earlier. Remember, I said this probably wasn't perfect, but if I kind of brought this down and tried to keep it the same without really stretching it, I see that it kind of pops into place there. It does look like that's probably about right. I mean, right? It's not 3.5 exactly. It's a little bit more. So this kind of verifies what we almost could see graphically. But again, the idea that whenever you add vectors, you're going to use the Pythagorean theorem to figure that out. And that's why I said addition with vector addition is kind of weird, because the direction matters. If I have two vectors that are orthogonal to each other and I'm adding them together, I must use the Pythagorean theorem to get the other side, or the magnitude of the other side. All right, I think I got a couple examples I want to look at. For example, this one. Add 16 meters per second east to 20 meters per second north. Now, again, I want you in the back of your mind to keep the picture in your mind, because I think that will help. But I'm not going to draw a really nice picture, as evident by my picture already. So 16 east is going to be like bam, 16. Okay, 20 north is going to be 20 north. Okay. The point is that if we want to add these together graphically, it's going to look like this. So I'm just showing you this so you understand the picture is going to be, we want this side, that's the Pythagorean theorem, because here's the right angle. So we're finding the hypotenuse. So to figure this out, you say, and by the way, something really cool here, you get, okay, look at this, c squared equals a squared plus b squared. Or if you want to get c by itself, you take the square root, right? So if you say c is going to be the square root of a squared plus b squared. There you go. So you can just solve it like that. Okay, so c is going to be the square root of a squared is 16 squared plus 20 squared. And it's time for me to use my calculator. And I got about 25.6. Don't forget your unit. Northeast. And by the way, this is a protocol you're going to see on the Google Sheets, but if I have like north and east together, I'm always going to put north first. If I had southeast, I would put south first. And that's typically how people talk about things. You know, if you said which direction you're going to go, you might say southwest. And few people say like east, north. It doesn't really, I mean, I guess it kind of makes sense, but not a lot. All right, northeast is really what we mean. All right, so simple enough. It's a pretty easy concept, really. But what happens if we throw a wrench in and add something else? Okay, you can do these later if you want. Okay, here we go. What if we do this? Well, I will tell you right now that you cannot add more than two vectors using the Pythagorean theorem. So how are you going to do this? What you have to do is you have to combine those that can be combined. I'm starting to have to rush myself a little bit because I've been talking too long. You have to start to combine these. So you have 3 meters per second north, 2 meters per second east, 4 meters per second south. There are two of those that can be combined, right? And it should be pretty obvious. The opposites, right? Because think about it. If I was going to, okay, imagine I'm standing here and I go 3 north. Okay, 1, 2, 3, and then I go 4 south. Okay, what have I really done? Well, I really only gone 1 south. Does that kind of make sense, hopefully? If you go one way then the other, you're kind of undoing what you did. So you can actually sort of combine, and I might have to actually just make another video, but you can actually combine these together. All right. So if you have 3 north, 2 east, and 4 south, these 3 north and 4 south can be combined. And if you combine them, I'm going to show you a better, more systematic way to do it. But hopefully you can see if you combine them, you're just going to have 1 south. And so then this problem turns into 1 meter per second south plus 2 meters per second east, which you can do easily. You can just use the Pythagorean theorem to do. And this is true of all vectors that we'll do. We are using 2 dimensions in these problems. Notice we're not talking about like up and down at the same time that we talk about north, south, east, or west. Because this is a 2-dimensional problem, by definition, 2 dimensions means that everything can be broken down into 2 coordinates. So I can give you a list of 100 different vectors, and they can break down into, they'll just be 1 north or south vector and 1 east or west vector. So that's how you're going to be able to add these, no matter the number. I'm probably going to make another short video showing just real quick an example of like adding, I think probably 3 or maybe more vectors, probably more vectors. And so I'll post that, and you should be able to find that as well.